for C, find the position of the particle when t equals 3. Now position, if you look back at this little picture, I went this way, back and forth, back and forth, back and forth. And it basically asking, where am I at t equals 3? Well, this was total distance. Well, if I just got rid of those absolute values, isn't that your position? Or your total change? But it's your total change, because you're summing velocities which are change. So if you're summing changes, that's good. It tells you how much you've changed, but don't you have to say where you started? So position is going to be, where did we start? We start at 5. So you start at 5 plus then the integral from 0 to 3 of v of t dt. That would be it. You start at 5 and then you're adding up all the change. Now you don't want the absolute value because the negatives are important, because the negatives take away position, and you need the negatives because you need these negative positions to move you left and right. And when you do that, your answer ends up being 5.773. You take the time to do that, that would be your answer. Now, D. This is a tough one to explain. D, for the whole interval, where is the particle farthest to the right? And then explain your answer. That's the pain. Farthest to the right. Now, if I look at this simple picture, it's really simple. Do you understand your answer? It's so quick. Your answer is simply by looking at the picture. Isn't it this one right here? Isn't it farthest to the right? Because every time you go back and forth, isn't it smaller amounts? So I know right away, isn't it going to be right here? By my picture? Yeah, that's it. Now how do you find that value? Well, can't you set your equation equal to 0? Can't you use your calculator and find out the zeros? Got it? Now, shouldn't all of these, to prove it, it is, without this little picture. If you can try to do this picture, you want to go for it. This picture could, in my mind, but they might be confused. It's not a very mathematical way of showing it. It's more of a visual. What you got to do to show it kind of is what's the farthest to the right is you kind of got to focus in on these points because these are turnaround points. Got it? So when v prime t equals 0, it's when you change directions. Are we okay with that? When v prime t equals 0, that's when we change directions. Sorry. When v of t equals 0. When the velocity equals 0, that's when we change directions. Now, I want to know when it's to the right. Isn't the right bigger values? So don't I want to basically find my maximum? So when I went farthest right, aren't I trying to basically find my absolute max of this, of C? This is problem C. I'm trying to find the absolute max of C. Now to find the absolute max of C, don't we set our derivative? Isn't this velocity? For a max, don't we want to know when, for maxes, again for a max, isn't that when v of t is going to change from positive to negative? Isn't that going to be a max? So isn't this the only possibility and this the only possibility? Got it? Aren't those the only possibilities of maxes? Or this? Or this? Aren't those circled ones the only possible maxes? Because that's a min. Doesn't it go from negative to positive velocities? So could we just check all those points? Yeah. So what we do is you first need to kind of describe these couple stipulations, and we got to think, okay, maximums, we're talking about these 4 points. Could we just plug in those 4 points to this function? Would that be good justification? Yeah. These 4. So what I would say is these values, what you do is you set, you basically, you're going to set v of t equals 0, And when you set v of t equal to 0, you end up, and you end up with these, and you set equal to 0, you basically get, you'll get a t equals 0 equals the first one is going to be the square root of pi. The second one ends up being the square root of 3 pi. And the last one's obvious, the square root of 5 pi. Those are your values. The one is circled in red. Okay. Those are your values. And then these are your, when it equals 0, and these are relative maxes. They're possible relative. The relative maxes. Actually, these are relative maxes. Take that back. These are relative maxes, and these are endpoints. So we're going to check the relative maxes and the endpoints. The reason these are relative maxes, how would you describe that? Is we went over here, and we noticed that for these, when we went, the velocity changed from positive to negative. Where are those? Those would be these two. The max, relative max. The relative maxes are when velocity changes from positive to negative, and there's these two values. So those two values are your relative maxes. So when you plug, you're going to plug all these three into the functions. And when you do that, you basically are going to end up with x of 0 ends up giving you 5, which is that's given. X of square root of, oh, by x of, aren't the equation for position x of t? X of pi gives you 5.895. X of the square root of 3 pi gives you 5.788. And x of the square root of 5 pi gives you 5.752. So those end up being your possible farthest to the right, which are the farthest max. And then all you do is you look at all these and find your smallest, your biggest one. Your biggest one is this one. So your answer is farthest to right at the square root of, or at when time equals blank. Now again, you could easily have gotten the answer by looking at this chart and went bam, there it is. But this is the mathematical way to show it. You probably need a little bit more, but again, I'm out of space.